be an overview of the collection software for the RFTS 3600, which is a high-performance, low-cost RF receiver capable of decoding GSM, WCDMA, and LTE. It can also be used for spectrum analysis, CW testing, and raw IQ capture. The collection software runs on Windows and Linux, and there's an API available if you wish to integrate the scanner directly into your collection system. The collection data is stored in what we call an RPF file. The data is written out using an open source library called Google Protocol Buffers. This means you can access the data directly using multiple programming languages, or if you prefer, we also offer text conversion. So the user interface is composed of 4 main pages. You can access them all by using the side menu. You've got the dashboard, the measurements, the navigation, and the settings page. On the other side, you have an action bar which has both context-specific and general actions. This will convert an RPF file to a text file. This allows you to start and stop collection. And this one will bring up the log. The dashboard page is an overview of the collection system. From here you can see the status of the receiver, the GPS info, the collection list, a map of your current location, and graphs displaying the signal levels of the various technologies. So let's take a closer look at the collection list. This specifies the frequencies and technologies you're collecting during a scan. To add an item, simply input the frequency or channel and it will search for all valid channels and frequencies. To demonstrate, let's type in 1940. You can see 1940 is valid for multiple technologies. For GSM, you can see 1940 is a valid frequency in the PCS band, and it corresponds to BCCH 561. Selecting this item will tell the software to decode GSM only on 1940. By selecting the one below, called GSM Sweep, we're telling the software to sweep the entire PCS band and decode every cell it finds. You can also see there are several options for WCDMA and LTE. We can also tell the software to collect raw IQ data on 1940, or collect CW on 1940. If we make this into a range, you can see we now have the option to collect all the GSM channels within the 5 MHz range, or collect the power spectrum across the frequency range. The buttons at the bottom allow you to filter by technology, and you can also expand the collection list to see additional information. This is basically a miniature version of the navigation page, which we will come to soon. Let's go ahead and start collection so we can see the graphs in action. For LTE, the cells are represented by the EARCN in the physical cell ID. The bar graph shows the signal level of the primary and secondary synchronization channels, along with the total power in the channel. For WCDMA, the cells are represented by the UARCN and C-pitch. The bar graph shows the RSCP and the ECI NOT. For GSM, the cells are represented by the ARCN and the BSIG. The bar graph shows the BCCH signal level and C to I. For CW, we show the frequency and its total power. For power spectrum, we show you the power within the frequency range specified by the user. Okay, so let's stop collection, sweep some bands, and go to the measurements page. LTE, WCDMA, and GSM are configured in the same manner. You have the spectrum in the top left. To the right, you have the decoded cells and their signal strengths. And to the bottom left, you have a spreadsheet of the decoded cells showing various data, including any layer 3 we've decoded, which is denoted by the expansion button. You can see a printout of the layer 3 by selecting the different system information blocks. As I said, WCDMA and GSM are set up in a similar fashion. For CW, we skip the spectrum plot. For power spectrum, we display the spectrum and a waterfall plot so you can see how the signal changes over time. Next up is the navigation page. As you can see, this is a map of New York. The green circle denotes your location, with the little triangle showing your direction. You can zoom in and out, click and drag. To track your position and keep it in the center of the screen as you move, click the button in the lower right-hand corner of the screen. The filled-in target shows that you currently have GPS lock. As you collect, a new layer colored in blue will be laid down showing you where you have been. When you stop collection, the layer will turn gray. There's an additional action in the upper right that allows you to manage the layers. From here you can import RPF files to show where you've already collected data. You can also import KML files if you need to show additional data on the map. And lastly, we have the settings page. Here you can change the collection and display parameters. The collection profile essentially allows the user to modify our collection algorithms. Right now we have two default profiles. Prioritize Layer 3, which allows the software to decode more Layer 3 but at a slower speed, and Fast Scan Rate, where you can only decode the CGI, and there's an emphasis on making sure all items in the collection list are measured equally and as fast as possible. You can specify how long cells stay up on the graphs. You can have the software automatically convert RPF files to ASCII after the collection is stopped. And you can also toggle whether or not the RPF files are added as map layers. Underneath General, you can change various parameters related to the collection of power spectrum, CW, and IQ data. You also have several options related to logging. So this concludes the overview of the collection software.